We are going to have now the exercise on the simulator. We are driving a motor in there. We are using the pulse width modulated output in this simulator. And then you can open the simulator, going to the taking a new page. And then embed OS simulator. And then you get an embed simulator. It's an online system and it's a working one. So there is a microcontroller in here, and then you can drive create a code here, add components from here, and then test what you will if you get it working. So let's have it over there, and then our instructions in here. So we need to go there, open the simulator. So please open the simulator in this kind of address. So there in the instruction sheet is exactly what you should be doing to get the motor simulator running. So please modify the PWM out demo. So we take first the PWM out demo, deleting the LED on pin 5 and adding a components. So these components, analog potentiometer, then the 2 LEDs as well. So loading a demo, PWM out, load the demo, and then deleting the component from the X in here. Yep, deleting the component and then adding the component. So analog potentiometer on the pin 15, another analog potentiometer on the pin 16, an LED, a red one, on pin number 15. No, sorry, 21. Because it needs to be one of the pins which is capable of driving the pulse width modulated signal. So it needs to be, for example, pin 21. And then still the blue LED on pin number 22. So if we were to find the definition which pins we need to use for the pulse width modulated output. So in the operating or in the hardware of the microcontroller, we will have a look on the exactly that board which we would be using on the laboratory. So in the laboratory, we would be using a board L432KC. It's one of the boards supported by the ARM embed system, and it's that one, Nucleo L432KC. And on the board documentation here, there is a nice drawing which is telling that which pin is used for what purpose. And then from that drawing, we can see that, all right, that pin is capable for the pulse width modulated output. That pin is capable for the pulse width modulated output, and that pin, and so on. So in that microcontroller, inside this integrated chip, there is the microcontroller central processing unit, and then there are also the peripheral units inside this really tiny small component. And some of those peripheral units are those pulse width, which are capable of producing the pulse width modulated signal. So actually the microcontroller program is not like running a program for generating the pulses there continuously when you drive a motor, but it's done in a very tiny small block on this integrated chip. and it does it in the hardware. It provides those pulses. And that piece of hardware is connected only to certain pins of the microcontroller. And then these pins on the edge of the board, only a few of those are capable of driving the pulse width modulated output. These with the PWM symbol in here. The controller they have here on the simulator is another one. So actually this board is not anymore available as a real board, but in this one they say that the PWM signals are these from 21 to 26. So that's why I have selected my LEDs also for 21 to 22. And then what next? So you have the components there on the simulator, and then after adding the components, you can copy this code into the simulator. But it's better not to copy paste from a PDF document. Sometimes it works, sometimes you get extra symbols in there. For example, if you copy from here, you would get also my heater text in here. So in the course page there, where you have the simulator instructions for this exercise, you also have a file for copying the copy of the code as a text document. Click that one. It is loading it for you automatically. Then you need to open it in the editor, like a normal notepad. And then you copy the whole code. And paste it to the simulator. And if you have done like it is told in the instructions in here, then now you should have the copy of the code, and it should be capable of driving a nice simulation.